Hello, today we are going to discuss about the case 2 Thevenin equivalent circuit. Now in case 2 what we have seen here, there is two type of voltage source. One is independent voltage source and this is your dependent voltage source. As you can see, this is dependent on this Vx, this is voltage across AB. Now how we are going to solve this type of circuit? This is case 2 problem. The case 1 was composed of only independent voltage source. Now here independent plus dependent voltage source both are there. Now here what we are going to do, here we are going to just find VTS and ISC, and by finding VTS and ISC we are going to calculate RTS is equal to VTS by ISC. Now if I assume this Vx is VTH, because here if this is the VTS we need to find, then this Vx will be VTH. Now suppose this voltage is equal to V, then the current will be current is coming this side. From here this current is coming because this is current source, and this current is not going to come through this side because this is open circuit. This current, the current coming through this must be equal to current going through this. Now what is this current? If I calculate this current I must be equal to VTH by 4000, or I can say I am saying I must be equal to VTH by 4K. And if I calculate I, then V minus 4 by 2, V minus 4 by 2 will 2K will give me I. Am now substituting this here, V minus 4 by 2K is equal to VTH by 4K. Now this V is nothing but your VTH, because this all the voltage applies across here. So this VTH is equal to this V is equal to VTH. Now I am replacing V by VTH minus 4 by 2 equal to VTH by 4. This now cutting 2 by 2. Now if I take 2 VTH minus A equal to VTH, now VTH is equal to 8. Now we got VTH is equal to 8 volt. Now how to calculate? Now we cannot calculate the RTH. Why we cannot calculate the RTH? Now the circuit, initial circuit was this one, 4 volt. This is 4. This is 2K. Now this was our initial circuit. Here it was VTH by 4K and this is 3K. Now why we cannot calculate RTH? Because we can short circuit this one, but what we will do with this one? If I short circuit also this one, we cannot determine the resistance across this one. So what we do, we find a short circuit. For that we will short this terminal. Once you short this terminal, this was your VTH or Vx. Now VTH will be 0 because of short circuit, then this will be removed. 0 by something will be 0 by something will give me 0, means this current source will be 0. Now what will the equivalent circuit? 4 volt, this is 2, this is your 3K. Now it was 3K only. Now complete this circuit. This is 2K and 3K. This is your 4 volt. Now if I calculate the current across this one, now current across this circuit will be, now I is equal to V by R. What is total V? Is nothing but it is 4 volt. Now it is 4 volt. I will be 4 by 2K plus 3K. It is 4 by 5K. It is going to give me 0.8 milliampere. Now this is nothing but your ISC. Now how to calculate RTH? It is just VTH by ISC. Now what VTH we have calculated? VTH is 8 volt, 8 by 0.8 milliampere. Now what it will be to 0.8 into 10 to the power minus 3. This will come here and this will give me 10. So 10 kilo ohm. So The equivalent model of this circuit is nothing but, what is this VTH we got 8 volt, followed by, we can replace this model with 8 volt followed by this 10 kilo ohm. Now this is our the Thevenin equivalent of this circuit. Now here we have seen how we have calculated. It was just simple, just to calculate VTH and ISC. Now we are going to take the another problem. Now this is your second problem where we are going to see the VTH and RTH. Now this is your also case 2 type of problem, because here independent voltage source is here and this is one in dependent voltage source. Now how we are going to apply? We are just going to find the VTH and ISC. For finding VTH, what we are going to do? We are just going to redraw this circuit. Now we are just going to look at the possible value. Now if this is your VTH, now this VTH it will be 0.01 VTH, this is your 20k and this is your 100 volt. Now if I apply KVL across this one, now what will be? VTH minus 100, this is VTH minus 100 minus this voltage suppose we have taken VA, minus VA equal to 0. Now VTH minus 100 minus VA. What is this VA? This current is just going to come through this branch. It will not going to this branch because this is open circuit. Now if, what will be the voltage? This current into resistance. Now what is VA? VA is nothing but 0.01 VTH into this 20 kilo ohm. Now if you calculate this one, this is 100, this goes here. Now what it is going to give me? This is 200 VTH. Now here if I write 200 VTH equal to 0, now what it is going to give me? Minus 199 VTH is equal to 100. Now VTH is equal to minus 100 by 199. So this is your VThevenin of this circuit. Now here for finding RThevenin, what we are going to do? We are going to find the ISC. Now I am again redrawing this circuit. This is our 0.01 V1. Now this is your 20k, this is 100 volt. Now I am short circuiting this one. If I short circuit this one, then VTH is equal to 0 or V1 equal to 0. When this V1 equal to 0, then this will blow up. Then what we are going to left with, this is 20 kilo ohm. Now this current is just going to flow in the circuit. What will be the current? I is equal to, now equivalent circuit will be 20 kilo ohm minus plus, and this is your ISC that will be flowing. What will be ISC? It will be 100 volt by 20 kilo. 100 volt by 20 kilo ohm. Now this is 5, ISC will be 5 milliampere. Now if I need to calculate RTH, how are you going to calculate? RTH is equal to VTH by ISC. What is VTH? Minus 100 by 199, it is 5 milliampere. Now if I take approx value, then for approximate calculation, what will be? It will be 200, 100 by 2, this is going to give me 2, and minus this is 10 into 10 to the power minus 3. Now if I take this one up, now around 100 we are going to get the RTH, around 100. We have not done the exact calculation, we have just give the equivalent because we have not used a calci. So this is the equivalent resistance across RTH. And what is this VTH? This. Now here we have seen that this is just calculated by finding VTH and ISC. This is case 2. Why? Because here one independent source and one dependent source is there. Now we are going to take one more problem regarding the dependent and independent source. Now this is again the problem of case 2 type, because here one independent source and this is dependent source. Now how we need to find the VThevenin and RThevenin across this. Now how we will find it by calculating VThevenin and ISC. So now what we are going to do, we are going to break in these two circuit, because it will be easy to find the VThevenin and RThevenin for this circuit. Now how we have found the VThevenin and RThevenin of this circuit. This is your 2 kilo ohm and this is your 2 kilo ohm. Now for this is just an independent source, so it is here easily we can find just by short circuiting this one. The RThevenin will be this one, 2 and 2 are in parallel, so 2 into 2 by 2 plus 2, so it is 1 ohm, 1 kilo ohm. So RThevenin we got it. Now for VThevenin the circuit is simple. This is your potential divider circuit. Now this is 5 volt and this is 2 kilo ohm. 2 kilo ohm means equally it will be divided 5 into 2 by 4, it is 2.5 volt. Now I can replace this circuit, this overall circuit, by 2.5 volt, and in combination with RThevenin, what is this, 1 kilo ohm, and now remaining equation can be written. This is nothing but 3 VAB and this is your 1 kilo ohm and this is your VAB. Now this is real VThevenin we need to find, so writing VAB equal to VTH. Now this will be VTH. Now applying KVL across this one. Suppose I current flows over here. Now 2.5 volt minus I into 1 kilo ohm minus, this is plus minus 3 VTH, and then again here it will be your minus 1 into 1 kilo ohm into I. Now what is this VTH? VTH is nothing but voltage across this one. Now what current it is following over here? I into 1 kilo ohm. So I can replace this by VTH and here also by VTH. This is equal to 0. Now 2.5 volt minus 2 VTH minus 3 VTH equal to 0. 5 VTH is equal to 2.5 or 5 by 2. 5 by VTH is equal to 1 by 2 volt or VTH is equal to 0.5 volt. We got it. Now after solving such a tedious circuit, we got a VThevenin is equal to 0. How we have solved? We have first broken this circuit into two parts. This is independent source and we have just calculated the VThevenin and RThevenin, the independent source. It is 2.5 and 1 kilo ohm. How we have calculated? Just by short circuiting. Now this is your 1 kilo ohm and by potential divider we got. Now here after applying KVL we got all this value. Now for finding ISC, because we cannot find our RThevenin directly because of this dependent source. Now if I need to calculate ISC, then what we are going to do, we are just going to short this terminal. When you will short this terminal, this will be having no effect, means, and when this is no effect, then VThevenin will go 0. Then now what will be the equation? This is 2.5 volt and this is your 1 kilo ohm and this is the current that is following ISC. ISC by will be 2.5 by 1 kilo ohm. Now this is 10 to the minus 3. ISC will be 2.5 milliampere. Now this is ISC we have calculated. Now we are going to calculate the RThevenin. Now for RThevenin will be VTH. What is VTH? It is nothing but half 0.5 by ISC. It is 2.5 milliampere. 2.5 milliampere. Now this will go over here, 5 ja, and this is going to give me 0.2 kilo ohm. So RThevenin of this circuit is 0.2 kilo ohm, and VThevenin what we have got 0.5 volt. And so this is another type of problem. Now we are going to see one more problem regarding this case. Here this is also a case 2 problem. Here it is independent source, and here it is dependent source. Now lastly what we have done, we have broken this circuit into two. We cannot break this circuit into two because this dependent source depend on this current I. So what we need to do, we need to just go in a normal manner, means we cannot break this one into. Now here we just need to find the VThevenin. Now this is your VThevenin we need to find. Now suppose this is your V. Now if I apply KCL at point V, then V by 1, this is 1 ohm, plus this current is going here V, and this is your voltage drop V minus this V, this is V plus voltage of this will be V plus 20I by 2. Now this is the current that will be flowing in this path, and V minus 2 by 1 equal to 0. Now this will be the equation of this is the equation of this circuit. Now if we see the calculation, now what we are going to get, this is V by 1 is equal to nothing but V plus 20I by 2 plus V minus 2 equal to 0. Now it is 2V plus V plus 20I by 2 equal to 2. Now it will be 4V plus V plus 20I equal to 4, means 5V plus 20I equal to 4. Now here if you see, I is nothing but V by 1, or we can replace I by V. Now 5V plus 20, because we can replace I by V, then 20V is equal to 4 and 25V is equal to 4, V is equal to 4 by 25. Now this is the V, we got it. Now for VThevenin what we will be doing, we are just going to apply KVL. Now VThevenin minus 20I minus this V will give me VThevenin. VThevenin is equal to 20I plus V. Now I was nothing but your V, so this will become 20V plus V. Now VThevenin is equal to 21V. Now what is this V? V is nothing but 4 by 25. Now VThevenin what we are going to get, 21 into 4 by 25, this is nothing but 81 by 25 volt. So this is your VThevenin of this circuit. So this is all about the case 2 type of problem. In case 2 what we have seen, the circuit will be consist of one independent source and one dependent source. So this is all about your case 2 type of problem of Thevenin.